Welcome to organic chemistry. This is a completely different track that we're going to take for the next couple of chapters. The mathematics, while there's a little tiny bit of it, for the most part, it's not going to involve calculators at all. So you can put those aside and let them rest, because they've probably been smoking for the past few chapters that we've done. First of all, organic chemistry is the dynamics of chemistry. It is 95% of all compounds that we know of. Minimally, could be even more than that now. The exploration into finding vaccines involves organic chemistry. The fact that we exist as an organic being is because of organic chemistry. This is about us in so many ways. This is the area that I really enjoyed being involved in when I was working on my bachelor's and my master's, was organic chemistry. So, don't fear it. A lot of people like it. A lot of people don't like it. They like the math more than this, but that's fine. But this is the most important and most relevant section that we are going to deal with as far as human beings are concerned. Definition of organic chemistry is that it is a carbon-based compound system, but it must have hydrogen as well. If it has carbon and not hydrogen, it is not considered to be organic. It has to have carbon and hydrogen. Now there are other elements involved, particularly oxygen, sometimes nitrogen, a little bit of sulfur, but for the most part, carbon, hydrogen, and a fair portion of time oxygen. So we are going to be splitting this into two sections. The first section that we're going to start off today deals with hydrocarbons. Hydro means hydrogen, carbon, really? Okay. So that means that we're dealing with compounds that are basically carbon and hydrogen. They are the simplest of the organic compounds, but they can be extremely complex, as you shall see. An example of a compound that has carbon that is not organic is sodium carbonate. You'll notice that there is no hydrogen here in sodium carbonate. It is not an organic compound. It's called an inorganic compound. The carbonates are not organic. Alright, so like I said, these are the simplest ones, and when we deal with organic chemistry, we're going to be looking at three areas. Physical properties, like for hydrocarbons, most of them are mainly, if not completely, nonpolar, and that has ramifications in boiling points and freezing points and densities and more. The nomenclature is a naming system. A naming system is important in organic chemistry because there are literally millions of these compounds. If you don't have an organized system, it would be virtually impossible to know the names. An organization known as IUPAC, or some people call it IUPAC, is the same organization that comes up with the names for the elements of newly found elements or made elements. These guys are geniuses. When you hear a name for an organic compound in its true systematic sense, you know exactly what the compound looks like if you understand the verbiage within the naming system, which is what we're going to start off today with our prefixes and suffixes. And the last thing we're going to talk about with organic compounds is how they react, how we create them, what happens when you get them, all that kind of stuff. So we are just going to scratch the surface of organic chemistry. I taught organic chemistry at the college level for 15 years. The books tended to be in the neighborhood of 1,000 to 1,500 pages thick. And so there's a lot of things that we could do with this. We're going to spend a couple of months at most on organic chemistry. So we are going to be a little limited in the content, but we're going to hit what we call the greatest hits. So enjoy. So the first thing I'm going to deal with is the nomenclature. Nomenclature means naming system. and it's based upon prefixes and suffixes. Okay, so we're going to do the prefix first. The prefix of the organic nomenclature is, we're just going to do the first 10. The first one is meth. That means you have one carbon. Meth means one carbon. F means two carbons. This is pronounced prop, not prop. This is prop. 3. This is pronounced but. At 4, Hep 5, Hep 6. These are predictable because they're pretty similar to the polygons and to the hydrate crystals that we dealt with as well. All the way up to dec for 10. All right, so just use that as a guide to figure out how these things start. Okay? Now, the suffixes is when we start to get into the differences of organic compounds, not so much the length of the chain. Now, when I say 4 carbons or 6 carbons or 10 carbons, I'm talking about consecutive carbons linked together. We call those straight chain compounds. And I'll show you what I mean in just a little bit about that. The suffixes describe the highest level of organic bond that we are, highest level of covalent bond that we have. Now there are 3 types of bonds that you've been associated with: single bond, double bond, triple bond. Remember those foam balls and the toothpicks, and we made the structures using Vesper. That's what I'm talking about. Okay? Now, the highest level bond determines the suffix name. Now, what I mean by that is this. You're going to have a whole bunch of single bonds there. But if you have a double bond in there, then it changes the structure of the molecule at that point where the double bond is. You have a triple bond, same thing, another change different from the double bond. And as a result, the properties change as well. Therefore, they are classified as different types of hydrocarbons. Okay? Now, let's make sure we understand. Now, let's suppose that we have a 2-carbon chain. And let's say that we have a single bond here, and these are all hydrogens right here. Now, this right here, the carbon-to-carbon single bond, tells us that that's the highest energy level, or highest energy bond, rather, that we have between the 2 carbons. And said, well, we only have 1 bond, and that's a single bond. So we end the name of this with an ene. Ene means single bond. Or that the highest energy level, highest bond energy level is a single bond. This is 2 carbons, and according to that chart, 2 carbon means F. The suffix is ene because we call compounds in which we have the highest bond is a single bond. These are called alkanes, generally. Alk means hydrocarbon. And ane means, of course, single bond. So, ethane is the name of this compound right here. And you notice that every carbon, now remember, every line that we make in a little dot structure represents a pair of electrons being shared. So this carbon right here has 2, 4, 6, 8 electrons when bonding to hydrogen. Now hydrogen only wants 2 electrons because all it has is a sphere at its outer level. So it just needs 2 electrons. So these all are satisfied. This is satisfied. This carbon over here, 2, 4, 6, 8 electrons. The octet rule is satisfied for both carbons. And so ethane is a very stable compound. And the reason that's important is because if you have compounds that are stable, they don't want to change. And therefore, they are not going to be reactive, at least not under normal sense. Now, there are exceptions, of course, and we'll talk about that in the next section with alkanes alone.